If you are still struggling with cue ball control and can't predict where it will actually go, this video is made for you. I'm gonna reveal the hidden truth behind physics, which has a key impact on cue ball control, but which surprisingly most players forget. I promise you, this one is gonna be a true game changer, so please make sure to prepare a cup of coffee and let's dig into it. Oh yeah, this is it. The first scenario shows straight-in shot and the natural behavior of the cue ball when we hit it soft with center ball. The cue ball rolls naturally forward in the same direction as the object ball, but if we use topspin with same speed, then we generate even more forward rotation, so the cue ball goes a bit longer than before. If we look at both shots more closely, there is practically no difference in the behavior of the cue ball, which simply rotates in place for a moment before starting to move forward. However, this behavior becomes much more noticeable when we increase the speed, because then the cue ball keeps rotating in place much longer before it finally starts moving forward. The more power the cue ball has, the more spin it carries, but it also grips the cloth longer, which creates this effect. A very interesting phenomenon is that if we hit the cue ball with high speed and use center ball, it practically stops in place, which is the complete opposite of a low speed shot. And this is because the cue ball has practically no spin when it contacts the object ball, so it only moves slightly forward. The situation changes significantly when we decide to hit low on the cue ball. However, speed also plays a huge role, because when we hit the cue ball quite lightly, it simply stops in place. And this happens because hitting low creates backward rotation, but with low speed the cue ball gradually loses the spin, and when it reaches the object ball there is no rotation left. We call it a stop shot, and what is very interesting is that we can create the exact same result using much more speed. We just reduce the amount of backspin. And very similarly to shots with follow, when we increase the power on a draw shot, the cue ball rotates in place longer, but this time it pulls backwards toward us, which is obviously caused by the backward rotation we created. We can actually distinguish two more types of shots, where in the first one we hit the cue ball just a tiny bit above its center and use very high speed, so the cue ball moves only slightly forward after contact with the object ball. We call it a stun shot, and it is a great alternative to slow rolling, but it definitely requires a lot of experience. On the other hand, we can execute a drag shot, which means we hit very low on the cue ball, but use relatively low speed. This time the cue ball starts with backward rotation, slowly loses it, and by the moment it reaches the object ball, it already has forward rotation, which makes it roll forward slightly. This type of shot is once again a strong alternative to slow rolling, and becomes very useful on long-distance shots. The biggest common feature of all these shots is the fact that the cue ball always travels along the same line, and this is obviously because we are dealing with a perfect straight-in shot. The situation becomes much more complicated when we start increasing the angle. This time the principle remains the same, the cue ball still moves in the direction we should, but now the differences become much more visible. We need to start with the stop shot to reveal one very important thing. A stop shot will always make the cue ball follow the tangent line, which defines an angle of 90 degrees. So it doesn't matter how much speed we use or how much we increase the angle, it follows the tangent line of that shot. And what is worth mentioning is that the tangent line only changes when we change the position of the object ball. Okay, so let's start with just a bit of angle and add follow to the cue ball. When we use low speed, the cue ball keeps moving forward, hitting the short rail at that point. But if we look closer, the behavior is almost identical to a straight-in shot, except now this small angle causes a small curve. When we use medium speed, the cue ball hits the short rail just a tiny bit further, but the curve becomes much more visible. The difference becomes huge when we use high speed. Now the curve is much bigger and the cue ball hits the rail much further than in the other two attempts. If we compare all three shots, then we can clearly see the influence of speed on the final behavior of the cue ball. Alright, but let's increase the angle of that shot to see what happens. This time we see a much more noticeable difference compared to the previous shot with the same speed. The cue ball hits the short rail significantly further and creates a much more visible curve. And the same thing happens when we increase the speed. The cue ball curves more and reaches the rail much further. This time the differences between each shot are more visible than before, which is obviously due to the increased angle. Okay, but what will happen if we attempt a draw shot? As you remember, when we played a draw shot with low speed, it resulted in a stop shot and the cue ball followed the tangent line. But when we use medium speed, the cue ball leaves this line and goes in the opposite direction, creating a clear and visible curve. And when we increase the speed even more, the cue ball goes much further to the side, creating a much bigger curve. So regardless of whether we play draw or follow, the cue ball always initially wants to travel along the tangent line. But what happens after depends entirely on the spin and speed we apply. If we have just a small angle and we try to roll the cue ball, it stays on the tangent line briefly and then starts going forward. But when we increase the speed significantly, it leaves the tangent line much later, which is why different speeds create different amounts of curve. Another important thing to mention is that the more angle we have, the further to the side the cue ball will travel, and of course it will stay on the tangent line longer before leaving it. However, executing all kinds of cut shots, we face one very important phenomenon called cut-induced draw, which means that the cue ball always pushes the object ball to the outside. This effect is most visible when we experience thinner cuts and we try to roll the ball with center ball. Very often this requires a slight adjustment in aiming or increasing the amount of speed, which significantly reduces the throw, so object ball is able to follow its natural path. And this is the moment where we need to talk about this situation. These two balls are frozen together in such a way that this combo is directed a bit more towards the side rail. Let's imagine that you put the cue ball right in front of that combo. If we hit the cue ball perfectly straight toward the A ball, then the 9 ball hits side rail here. However, if we hit this combo on its right side, then the 9 ball goes even more to the left, but if we hit on the left side, then the 9 ball goes perfectly towards pocket and even does not touch the side rail. And this is caused by the cut-induced throw factor, which makes it possible to send the 9 ball further down the table and pocket it without bigger problems. To reduce the throw, we can also use side spin on the cue ball, which very often creates a lot of confusion. If we hit the cue ball with right spin, it rotates with right rotation, and if we hit it with left spin, it rotates with left rotation. So from our point of view, if we play follow with right spin, then after contact with the rail the cue ball goes to the right, and if we play follow with left, it bounces to the left. However, when we play a draw shot, the situation changes a bit, because this time if we play low right, the cue ball after contacting the rail will go to the left, and if we play low left, it will go to the right. Using side spin, we also experience something called spin transfer. This means that when the cue ball makes contact with the object ball, it transfers a bit of spin that is opposite to the one it currently has. So when we hit with right spin, the object ball receives a bit of left rotation, and when we hit with left spin, the object ball receives some right rotation. This can be very important when executing bank shots, where sometimes we must use spin to manipulate the object ball's path. Let's assume we face a situation where we need to play a one-rail bank shot into the side pocket. If we draw a line through these two balls, we can clearly see that this line goes from this point to this point. And this means that if we hit the object ball perfectly straight using a bit of topspin and natural speed, then after contact with the rail it will go toward the side pocket. However, if we play the same shot using left spin, the object ball goes long, but if we apply right spin, then the object ball goes short. And now I need to mention this very interesting A-ball scenario where we need to execute a bank shot on the final A-ball into this corner pocket, because this pocket is blocked by a solid ball. The main problem in this situation makes this solid ball, which partially blocks our correct aiming point on the rail. To make this bank shot possible, we need to hit the A-ball behind the solid ball, applying more speed and using a lot of right spin, because then the A-ball will have some left rotation and the angle of reflection will shallow, so the A-ball goes towards the corner pocket. And similarly, if we slightly change the position of the solid ball, then we need to hit the A-ball before this ball, but this time we need to apply a lot of left spin and less speed, because then the A-ball will have some right rotation, which causes it to open more angle and go towards the corner pocket. But when talking about the influence of side spin, we must remember three very important terms: deflection, swerve, and spin-induced throw. Deflection means that when we use side spin on the cue ball, we push it off its original line. How much it deviates depends on the tip offset, shot speed, and the quality of equipment. However, the most important factor is speed, because the harder we hit the cue ball, the more deflection we create. And this brings us to the second important term, called swerve. When we hit the cue ball with side spin, at first it deflects off its natural line, and after some time it curves back toward that line. A huge influence on how strongly this happens comes from the tip offset, the shot speed, and the elevation of the cue. However, most importantly, the more we elevate the cue and the less speed we use, the more swerve we generate. And with this move step, we move into the last important term, called spin-induced throw. As mentioned earlier, when we use side spin, during contact with the object ball, the cue ball transfers some opposite rotation to that ball. But at the same time, this spin also pushes the object ball slightly to the certain side. When we use right spin, the cue ball pushes the object ball slightly to the left, and when we use left spin, it pushes it slightly to the right. All these terms are extremely important, and we always have to take them into account when playing with side spin to choose the correct aiming adjustment. It is worth understanding what actually happens to the cue ball when we send it toward the rails, which becomes very useful when executing one-rail kick shots. Let's imagine the cue ball is placed somewhere on the table, and if we draw a line from this diamond to this diamond, we can see that it lies perfectly on that line. And this means that if we hit the cue ball exactly along this line, it bounces off the rail at exactly the same angle and goes towards the side pocket. So this is our first very important piece of information. The angle of reflection will be equal to the angle of incidence, but we need to remember one thing. This happens only when we hit the cue ball slightly above its center while using natural speed. The spin and speed we apply have a huge impact on the angle of reflection. We need to pot the one ball, but the cue ball is blocked by the free ball. Let's assume we managed to find the correct contact point on the rail, and if we hit the cue ball slightly above its center using natural speed, it travels with natural rotation along the correct line and hits the one ball. And this line will be our reference when comparing the impact of spin and speed. If we use natural speed again, but this time apply topspin, the angle of reflection widens because the topspin wants to pull the cue ball in that direction. So in this case, if we try to hit the cue ball with low spin, then this spin wants to bring it to the opposite direction. And the situation becomes very similar when we use side spin. If we hit the cue ball with left spin, the angle of reflection widens once again, but as you can see, the path looks a bit different, because after contacting the rail, the cue ball changes direction immediately. So in this case, when we hit the cue ball with right spin, the angle of reflection becomes shallower, and the cue ball touches the long rail first. Alright, so now I'm gonna show you how to use this knowledge in two different scenarios. We are on the 4 ball and the next is 5 ball, which is blocked by the 6 ball. We remember that if we play a stop shot, the cue ball will follow the tangent line, but this time that is not enough because the cue ball travels too short. To reach those balls, we must leave the tangent line in this direction, and we can achieve this by hitting the cue ball lower. However, as you can see, now the cue ball goes too long, so in this case we have to hit a bit higher and simply use more speed. We need a touch of luck to get a clean shot on the 5 ball, but this was our first example of how we can predict the cue ball's path while opening clusters. The second example is about positioning and how to get perfect shape on the next ball. We need to get from the 4 ball to the 8 ball, and I believe the most common choice would be this 2-rail shot, but do you actually know how to play it properly? If we try to play a stop shot and use tangent line, you can see that the cue ball goes straight toward the bottom right corner. We need to hit bottom rail first, and we can achieve this by hitting the cue ball at its center. This path looks much better, but as you can see, the cue ball doesn't have enough speed to reach the optimal area. To give the cue ball more speed, a great solution is to add some outside spin, because then we can effectively extend this path and get the perfect shape on the 8 ball. Okay, but if this path is blocked, we must find another solution. If we hit the cue ball with topspin, it follows its natural path and avoids the blockers, but that is definitely not the shape we wanted. We need to pass the blockers on the left side, and we can do this by applying top inside spin. Alright, but even this path can be blocked, and now we are forced to use the right side of the table. We remember that when I played with topspin, the cue ball followed its natural path toward the top right corner. So in this case, to get perfect shape on the 8-ball, we must add a bit of left spin and use more speed, which widens the angle of reflection on the bottom rail and guides the cue ball around the table. And the key here is speed control to land close enough to the 8-ball. If you are still here and you enjoyed this video, then please consider leaving a thumbs up as well as subscribe to my channel to never miss videos like this. Thank you very much for watching and see you in the next video. Take care.